This is the continuation of the 1B review packet, starting off with number 47. It says two angles form a linear pair, and the measure of one angle is 15 times the measure of another angle. Find the measure of each angle. So if you need a diagram to understand this, linear pair means it has to be on a straight line, they're adjacent, and these two angles, I'll just call them 1 and 2, have to be, one is going to be x, the other one will be 15 times x. So when I add them up, x plus 15x, I have to set that equal to 180 because it's a linear pair. And when I'm solving here, I divide by 16. 16x equals 180, divide by 16, and that's how I end up with 11.25. So that the measure of angle, I'll call it angle 1 because I labeled it like that. You could just call it measure of angle and do 11.25 degrees. For the second one, measure of angle 2 here would be 15 times 11.25, which comes out to 168.75 degrees. Make sure you have degrees because those are the units. Let's continue. So the next one says the measure of one angle is 47 less than the measure of its supplement. So if one angle is x, then I want to do 47 degrees less than that, and then I know that they're supplementary there. So I want to add these two together, set it equal to 180, and solve for each of the two angles. So this comes out to 2x equals 227 once you add 47, divide by 2 so that you get 113.5. Again, that's for one of the angles, and then you could write it as either measure of angle equals 113.5 degrees. The other angle would be 47 degrees less than it. So subtract 47 from this, and it's 66.5 degrees. But together, those two angles add up to 180, so you know you did that correctly. Number 49, we have find the values of x and y. So when this happens, you notice that you don't want to use x and y in the same equation, but I could use these two x's because they're on a straight line. It's a linear pair. So I can say 25x plus 8 plus 9x plus 2 adds together to 180 because they're a linear pair, and then continue solving. So 25x plus 9x would be 34x, 8 and 2 is 10, and subtract and divide to figure out what your x is. So 34x would be equal to 170 once you subtract 10. Once you divide by 34, you get 5. So if x is 5, we're done there, but to find y, I actually do have to take this 5 and substitute it back in. So 25 times 5 plus 8 comes out to, actually I didn't write that answer, but I can calculate it real quick. So 25 times 5 plus 8 comes out to 133. So if this is 133 and it's a linear pair with 7y plus 5, you can either do 7y plus 5 plus 133 equals 180 like that. You could have also used 7y plus 5 equaling 9x plus 2 because those are vertical angles and do it that way instead. But again, lots of ways you could solve this. So I'm going to subtract 133 and 5 from 180 to get 42, and then y would come out to 6. So we found x and we found y. The next two questions, you're just filling in whether it's always, sometimes, or never. It's good to kind of justify to or explain. I'm not going to explain in words so much, but I can walk through it. It says two vertical angles are adjacent. So in order to be vertical, they have to be straight, two lines that intersect to be, the angles that are created are across from each other. While in order to be adjacent, they cannot be across from each other. They have to share a common side. And they would share a common point in that case, but the common side would not get shared. So this is never. And your reason is because adjacent angles must share a common side, whereas vertical angles would not. So there's no way that vertical angles could also be adjacent because verticals are always across and adjacents are always the ones next to. An angle that has a complement also has a supplement. Now that's always true because if an angle has a complement, so think of any angle at all, that when you add to another angle it has to equal 90 degrees, then that same angle could add another angle to it and it could equal 180 degrees. So that will, there's no example where that could not work. So that's why that one's going to be always. All right, the next one we're working 52 with the supplementary angles. If we know they're supplementary, we're adding them up, setting them equal to 180. So these two equations added together equals 180, and then just doing some algebra here, this would be negative 8x, this would be 240, and equals 180. You want to subtract and divide to finish up. So this comes out to negative 60. Once I divide, I get x equals 7.5. That's x, but remember the question said to find the measure of angle A and B separately. Each of them is going to be different. They're not the same, right? They're supplementary. So negative 3 times 7.5 plus 90 comes out to the measure of angle A equaling 67.5 degrees. And then same idea for the second one, negative 5 times 7.5 plus 150 comes out to measure of angle B equaling 112.5. And together those two are supplementary. They add up to 180. Number 53 says tell whether the two angles are complementary, supplementary, or neither. It's referring to this one and this one. And technically this one isn't quite up and down so that it's not exactly 90 degrees, but since this is slightly less than 90 and then this is slightly larger than it by the same amount because of how many minutes it is, those two together would be supplementary. Okay, the sum would be 180 degrees, so supplementary. And then from this diagram with the triangles, we're trying to figure out some supplementary angles and adjacent angles. It says identify two pairs of each kind. So supplementary has to just be anything on a straight line. So we have angle 2 and angle 3. So another pair of supplementary angles from this star would be anything that's on, and again, on a straight line. So we'd have angles 5 and angle 4. You could name 7 and 8, 9 and 10, 3 and 4, 7 and 10, so lots of different angles possible there. Adjacent angles would be any two angles that are next to each other, sharing a common side and a point also. So we'd have angles 2 and 5 again, or 2 and 5. Another example could be 2 and 3. But again, multiple examples are possible here. 2, 3, 3 and 4, 5 and 4, 8 and 9, 8 and 7, 7 and 10, and so on. So I listed a few here, but you can definitely pick others. And onto the last page here, we have some Pythagorean theorem over and over again to make sure you practice and know what it says, how to apply it. So we have one leg given, here's another leg, so we're going to do 25 squared equals 18 squared plus x squared. Then subtract 18 squared from 25 squared, you get 301 equals x squared, and then square root it. So we get the square root of 301. That is in simplified radical form. The next one we have x squared and 9 squared equals 27 squared. Comes out to, when I subtract the 9 squared, it'll be 648, and square root it. This one does simplify it to 18 root 2, because the biggest perfect square in there would be 324. And then finally, the next one, number 3, you have two legs here, x squared and 36 squared, and then 42 squared. So we're solving for the leg again, so you want to subtract 36 squared from 42 squared, and you get square root of 468, square root it, and you have 2 root 117. So again, the simplified radicals on these, I wouldn't worry about too much for the quiz tomorrow, but for the summer packet quiz, you do need to know how to simplify radicals as well, and we do it all year round, so you want to make sure you eventually do get better at those. For 4 through 6, you are going to use Pythagorean theorem maybe multiple times. So, and this first one, though, it's not as often. Since 8 is there and there's a bunch of tick marks for the 8 that are all congruent, this triangle that we're working with to find x would be leg lengths 8 and 8. So 8 squared plus 8 squared equals x squared. 64 and 64 is 128, and then you're square rooting it. The square root of 128 you can simplify to become 8 root 2, because the biggest perfect square sitting inside there would be 64. Number 5, you have to do Pythagorean theorem twice. Once to find this segment, which I called y, then you can find x. So it's 12 squared equals 6 squared plus y squared. And when you subtract the 6 squared and square root it, you should get 108 for y, square root of 108. Once you square root that, that does not simplify any further. Same idea for the x now. So you want to do the square root of 108 squared plus x squared equals 14 squared. Now the square root of 108 squared is just 108. So this is what we're looking at. Then I subtract and I square root to find my final answer, which comes out to 88. And when I square root 88, I can write that as 2 root 22. All right, and finally this one too, we have a bunch of letters to find. We have to find y and z here, because in order to get to this last triangle, we have all those pieces to find. So 3 times we're doing Pythagorean theorem here. So this would be 16 squared plus z squared equals 24 squared. Just for the sake of time on this one, I'm just going to tell you what I get for each of these. Once you subtract, you get z is square root of 320. And I'm not writing in simplest radical form, even if it's possible here, because I will need to just make sure my final answer is in simplest radical form. So I use that square root of 320 to now use 14 squared and square root of 320 squared to get y squared. And that comes out to 516. And I want to square root it. So y is the square root of 516, which again I'm not simplifying because I will need to simplify my final answer. And finally, to find x, I have the square root of 516 squared plus x squared equals 32 squared. And when I use my calculator to subtract 516 squared, which the square root of 516 squared, which is 516, from 32 squared, you're looking at 468. And then we square root it. This one I do need to write in simplest radical form, so you can practice that. It comes out to 2 root 17, or 2 root 117. But again, if you're having trouble with that for right now, we'll have time on Friday to go over some packet questions as well. So this comes out to 2 root, or this perfect square sitting inside is 4 times the 117. All right, for the last 3, before the last 3 diagrams with the triangles, we have to check whether it is a right triangle. So you take 2 sides and you say a squared plus b squared, does it equal 3 root 61 squared? And you're just, again, asking yourself this. So since the left side was 549 and the right side were 549, this would be yes, it is a right triangle. Do the same thing for 8. It was 21 squared plus 33 squared, and that does equal, same thing, 1,530 equals 1,530. So yes, another right triangle. But then the last one, 15 squared and 28 squared, does not equal 5 root 37 squared. If you weren't sure, you could check on a calculator, but it was like 1,009, and the other side was 925. And to know whether, which side is the hypotenuse, or which side you should put as the other side of the equal sign, you need to type these into the calculator if you're not sure what they equal, or if they're bigger or less than the other 2 sides. And so each of these radicals were the biggest sides for these triangles. All right, numbers 10 through 12 and also 13 were straight kind of from the homework assignment as well, where you just want to think of both possibilities that you can have. There are 2 possible lengths that you can find on this right triangle when you're given 2 sides, because it could either be these are 2 legs and I'm trying to find the hypotenuse. This is how you would do that. Or, and let me tell you what this comes out to, C is 10 in this scenario, or I could have 6 squared and b squared, and I'm trying to figure out what the leg is given, oops, this is 8. Given that 1 is a leg and 1 is the hypotenuse, this scenario gives me the square root of 28, which you can either write as the simplest radical form, or I'm just going to round it, so it's about 5.3, and this is in feet. All right, same idea for number 11. If you do 8 squared plus 17 squared equals c squared, it comes out to approximately 18.8 inches. But if you do 8 squared plus b squared equals 17 squared, and to find b, it comes out to 15 inches. And finally, the last one, 7 squared and 24 squared, comes out to c squared, where c is 25. But 7 squared plus b squared equals 24 squared gives me that b is approximately 23.0 if you round that up. It was about 22 and some. And finally, the last one, you're making a canvas frame for a painting using stretching bars. The rectangular painting will be 6 inches by 8 inches long. So that's 6, this is 8. You basically just have to draw the diagonal, because that's how they're going to be certain of 90-degree angles, if 6 squared plus 8 squared equals c squared, where c equals, I think it was, let's see. Actually, we just did it up here. C was 10. So if you can make it so that your it's 10 inches, the diagonal is 10 inches in length, then you will have 90-degree angles. And so I have a better response kind of written out in words there on the answer key if you'd like to see that in more detail. But this is the end of the review packet for Unit 1B quiz. And again, the answer key is also posted.